here. All right, everybody see that? Everyone can see
I
this?
can see it.
Yeah. All right, bonus marks if anyone can identify.
Isn't that a Link from Legend of Zelda?
Yeah, you got it. All right, perfect. Exactly. So this is my Link to the Past lesson. So we're kind of going over a few things here. Before we move on to the idea of parallel and perpendicular lines, we have to go over a few things that we already learned. So in this case, let's talk about equation of a line. What's the standard equation of a line? It's some kind of formula. I can hear someone very quietly whispering it. Very good. Y equals mx plus b. Awesome. Okay, so that's kind of been a key of what we've been learning so far, is that that's the equation of a line. What about, does anyone remember standard form? What was standard form? We talked about this briefly as well.
Was it ax plus by plus c is 0?
Very good. I'm very impressed. Awesome. Okay, so that's standard form. And again, we don't use standard form that often, but sometimes we do. And you'll see it again when you take grade 10, and there'll be reasons, we'll go over why you might rearrange something into standard form. And then there's this last idea, something called a negative reciprocal. Now, we've never seen this, I don't think, in our course, but maybe you've seen this before in a different grade. Have you seen this before? Anyone seen this before? Anyone know what that is? Negative reciprocal?
I think it sounds kind of familiar, but I don't actually know what it means.
Okay. So reciprocal is kind of like opposite. All right? Or and then negative is like flip the sign and be opposite. So and in fact, I'll put it like this. Change sign and flip. That's basically what's going to happen. So when we have a negative reciprocal, if we have 3 over 4, the negative reciprocal is you flip it and just change the sign. So it'd be negative 4 over 3. All right, so here we have negative 2 over 5. So negative 2 over 5 becomes what?
Would it be 5 over 2?
Yep, exactly. Just 5 over 2, right? Because the sign changed. So I'm going to put the positive sign there, but just to show you that it's changed. So we flip it and we change the sign. That's all that we're doing. So when we say negative reciprocal, that's what we're talking about. Okay, what about this last one? This one's kind of trickier. Negative 4. How do we do that one? Negative 4 is going to something, so we can change the sign. It becomes positive.
Would it be a quarter?
Exactly. Very good. Right, because right now it's 4 over 1. So like any solid number, right, 3 is the same thing as 3 over 1. So if we do negative reciprocal, we change the sign and it becomes 1 over 4, or a quarter. So likewise, if we had 5, 5 becomes negative 1 over 5. All right, so the negative reciprocal is going to be important to what we're doing today. So all we're doing is flipping and changing the sign. And I'll show you why it works that way. So we're going to look at, let's go back to where we were. The idea of taking this equation of y equals mx plus b. And we know that m is the slope. M is the slope. And then that b is the y-intercept. So we're going to look at two different specific cases of the lines here. So let's look at parallel lines. We're going to start off, though, by looking at the sets of lines here. So two lines are parallel if they are kind of side by side, and they'll never cross. Basically, they will never, ever cross. And they're kind of like symmetrical. They're side by side. All right? So it goes on all the way to infinity. So let's look at a couple different examples. So let's find the equation of each line. So again, if we're finding equations of lines, we're going to use the slope-intercept method, right? So we can see here, for example, the red line, I have a y-intercept of 1. And then if I did my rise and run, right? So my slope here would be rise 1, run 2. So therefore, y equals 1 over 2 x plus 1. All right, now let's look at the other one. So we have a y-intercept here of -2. And we'll do the same thing we were doing before with our rise and run. So it goes down 2 and over 3. So down 2 is our top, our rise is -2, and our run is 3. So therefore, y equals -2 over 3 x minus 2. All right, so there's our two equations. What about the other one? So in this example over here, I see that I have a y-intercept of 2. And if I do my slope, I'll do my rise and run. I'm going to go down 1 over 3, because those are my 2 points that work really well. So I have -1 plus 3, so slope is equal to -1 over 3. So therefore, my equation is y equals -1 over 3 x plus 2. Let's do it on the other line. Intercept, the y-intercept is -1 this time. And we'll do the same idea. So if we look at the lines, we can tell that the slopes are actually going to be the same, because the rate of change in both lines is the exact same. So therefore, y equals, again, -1 over 3 x minus 1. So we can see that the slope on both of those two equations is the exact same. So parallel lines have the exact same slope. The y-intercepts are different, but the slopes are the same. All right? All right, so they have the same slope. So if I were to look at down here, it says write an equation of two lines that are parallel to this line right here. All right, so the first thing I have to do though is, right now it's in standard form. So before I can write other lines, I need to put it into the slope and y-intercept form. So that's going to be my first step. So let's do that first. So I want to get it so it's in the kind of y equals format. So if I have 5x, I'm going to rewrite it out here. I'll rewrite it off to the side here. So I want to get into the y equals format. So I'm going to shift a few things over. Right? I'll take these guys and I'll get it to go to the other side. And that'll go to the other side as well. And when it goes to the other side, it changes signs. So I'm left with 3y is equal to negative 5x plus 6. Now, the next step again is I want it to get into a just y equals situation. So I will divide every term by 3. And that gets rid of the 3's on that side. So I am left with 3 equals negative 5 over, or sorry, y equals negative 5 over 3x plus 2. Because 6 divided by 3 is 2. All right, so there is my equation. All right, so if I want to put parallel lines in, I would use the exact same equation, or with the exact same slope, so I could go y equals negative 5 over 3x, but just change up the y-intercept. So I could go like this, negative 2. Or all right, so I just picked those numbers randomly. All right, because they could have been any number. All right, any number that's not plus 2, and those lines will be parallel. All right, what about writing the equation line that's parallel to y equals 1/3 x minus 5? That passes through this point. So we're given an extra little thing. It has to go through that specific point. How are we going to find that equation if it goes through this point? Any ideas?
Don't you just substitute them in?
Yep, we will definitely substitute in the x and y. So let's look at the equation for a second. So we had y equals 1 over 3x minus 5. And we're going to substitute in the x and y. So I got my y is 1 equals okay, so there's one thing that's wrong with this. Why isn't this going to work? A couple things that are wrong with it. Hold on. Come on, eraser. There we go. Erased too much, but that's okay. Okay, why isn't this going to work?
Because we have to solve for the y-intercept.
Very good. That's exactly what we need to do. All right, so we need to solve for b. So instead of negative 5, because that's that line, we want to find a parallel one, we need to find the y-intercept that uses those 2 points. So now we can solve it. All right, so then we're left with 1 is equal to 1/3 times 6 is kind of like 6 over 3 plus b. 1 equals 2 plus b. b equals 1 minus 2. b equals -1. So therefore, y equals, then we put our same slope in that we had before, 1/3x, and instead of -5, we put in -1. So that's our equation. Y equals 1/3 x minus 1. All right, so that was parallel lines. So basically the takeaway essentially is that parallel lines have the same slope. So we kind of just built on that with the last 2 examples. Using that same knowledge, what are the equations of the lines? Okay, in this case here, 2 lines are perpendicular if they meet at 90 degrees. That's kind of the rule for perpendicular, right? So it's kind of a straight out intersection with a 90 degree. So let's look at an example below with, we're going to graph this line. All right, so we're given a slope of 2/3, and we're given a y-intercept of 0. So there's our 0, our y-intercept, and 2/3. So slope is equal to 2 over 3. So remember, that's our rise over our run. So from that point, that 0 point, we can rise 2 and go over 3. And there's our point. And again, if we really wanted to make it accurate, we could make sure that we go over again. So you'd go up 2 over 3, so we know the next point is here. Sometimes having a third point can just make it a little bit, remind yourself where it has to keep lining up on. Okay, it's going to be a little bit off, but close enough. Okay, and when we put a line on, we should usually label it. So when I say label it, I'm just going to put an arrow and go y equals. Okay, so we want to put on a 90 degree angle. So if we look at it, we're going to find, we can do it using a protractor. So in this case here, I'll just use my ruler. All right, so if my ruler said I had 34 degrees, so 90 degrees, so we could add 90 if we wanted to. So 34 plus 90 is 124. Actually, you know what? Maybe the other way would be better because it's going this way. Okay, 34. Yeah, so we're going to go this way. So it gets to 90. So that's 56. So we have to add another, what, 34? Yes. All right, so this will be my 90 degree angle-ish. Okay, so I've tried to be really careful here, and I'm going to put a little symbol in here that shows it's 90 degrees, which is this here. It shows it's a right angle, and I'll even label it. That's 90 degrees. Okay, so now I have my perpendicular line on there. So let's calculate the slope of the perpendicular line. So we do the same thing. We have the y-intercept. I just left it the exact same spot. And we will go down. So it goes down 3 and goes over 2. And if you really wanted, you could try it again just to see if it verifies. And it does. That was pretty accurate when I was doing it there. So either way, you don't have to do the second one. The whole point is that this is our new rise and run for the perpendicular line. So we can say that our slope, right, is the rise and run that we have on that one. And I'm going to go like this. This little, I'll put the symbol actually, that's for perpendicular. All right, and so we said our rise and run was -3 over 2. So therefore our slope of the perpendicular line is -3 over 2. Now what do we notice compared to the original line? Let's look at the slope to the perpendicular line to the regular line. The first line we did. The slope was 2 over 3. What we should be noticing is what we did at the very beginning of this lesson, the idea of the negative reciprocal. So a line that is 90 degrees from another line, the slope is a negative reciprocal. So this is where fractions and slopes are really important. Like if you just had a number with a decimal and you said 0.667 or whatever, well, it's going to be hard to find the negative reciprocal. Like the fractions is how you solve it pretty quickly. So that's why we often leave slope as a fraction. So in this case here, our two lines that we have, these slopes are negative reciprocals. All right, so let's start off really easy. Write the equation of two lines that are perpendicular to this line. Well, we have to look at the slope that's right here. So of the regular one is 3 over 2. So therefore, the perpendicular slope would be a negative reciprocal. So it'd be -2 over 3. Therefore, we could write two lines and say y equals -2 over 3x and just make up any number. It doesn't really matter. Again, you can just insert whatever y-intercept that you want. It really doesn't make a difference. So both of these lines are perpendicular. They'd be cutting through the first line at a 90-degree angle. All right, let's go back to the idea of standard form. So remember, standard form and we have to convert to slope and y-intercept form. So in this case here, I have -6y. And again, I want y by itself. So I tend to like to leave my y on the left side, so I'm going to leave it on that left side. And I'll just go like this, -4x minus 18 minus 4x minus 18. So I'm left with -6y equals -4x minus 18. And I want to get rid of that 6. So I'll divide everything by -6. And these will cancel. And I'll be left with y equals -4 over -6 x. And I have -18 over -6, which I can simplify to 2/3, because a negative over negative is positive, and 3. So there's my equation. So I want to do perpendicular. So I have to take the slope and do the negative reciprocal. So I'm going to say, therefore, the negative reciprocal slope is -3 over 2. So my final answer would be, therefore, y equals -3 over 2x plus 3. And I could try another one. Again, the y-intercept doesn't matter as long as we have the slope correct. So I can pick any value for b. All right. Okay, so let's do a quick kind of recap here. So this will be pretty easy. And this is something you might see on a test just to kind of get some easy marks for you. These two lines are what? Are they perpendicular or parallel? Yeah. Yeah, they're parallel. Awesome. What about these two? It should be pretty obvious, really. Perpendicular, and the last ones are also perpendicular. Because, again, we have this kind of like okay, so, and these ones I'll leave for you to do, because I think I did the examples enough for you, and there's some questions on here. So, yes, the rest is yours for you to do, even though there's a lot of practice in there. You don't necessarily have to do them all, but try some to just make sure you get the gist of it. And, yeah, so that's perpendicular and parallel lines, everyone. And I will be updating the marks. I'm doing some grading right now, so if you want to check up what you got on any particular quiz, go right ahead and check in there. I'm doing it this afternoon, and if you have questions, you can always send me a message on Teams, but otherwise we are finished for today's lesson.